Myself Tarun, studying in Shri Venkateswara College of Engineering as CSEI. Today's topic I am going to discuss about machine learning algorithms. Machine learning algorithms are powerful tools that enable computers to learn and make predictions from data. Without being explicitly programmed, these algorithms form the foundation of modern artificial intelligence, unlocking new possibilities in fields like healthcare, finance, and beyond. They are essentially mathematical models that learn by being fed data, often referred to as training data. Common types of uh, ML algorithms. A machine learning algorithm is a set of rules or processes used by an AI system to conduct tasks, most often to discover new data insights and patterns. Supervised learning algorithms. In this regression classification and time series, in the regression, algorithms that predict continuous output values like housing prices or stock prices. In the classification, algorithms that classify data into discrete categories like spam detection or disease diagnosis. In the time series, algorithms that make predictions based on sequential data like forecasting future sales or weather patterns. Unsupervised learning algorithms. In this clustering, grouping data points based on similarities useful for market segmentation or anomaly detection. In the dimensionality reduction, identifying the most important features in a dimensional data, enabling visualization and faster processing. Association rule mining, discovering hidden relationships in data which will recommendations or fraud detections. End-to-end machine learning projects. In this data collection, gathering and processing the necessary data for the project. In the model training, selecting the most appropriate machine learning algorithm. In the model evaluation, validating the model's performance and the necessary improvements. Support vector machines and kernel types. In this linear kernel, suitable for linearly separatable data, creating a linear decision boundary. In the polynomial kernel, useful for complex non-linear relationships in the data. Radial basis function kernel, effective for a wide range of non-linear problems and image recognition. Bagging and pasting techniques. It involves several steps. First one is bootstrap sampling. In this, generate multiple subsets of the training data by randomly sampling with replacement. In the train models, train a separate model on each subset. In the aggregate predictions, combine the predictions from all models, typically by averaging or majority voting. Advantages of bagging: reduces variance and helps prevent overfitting. Models trained on different subsets capture diverse aspects of data. In the pasting is similar to bagging but without replacement. In this random sampling without replacement, train models aggregate predictions. Advantages of pasting: similar to bagging, it reduces variance and can capture diverse data aspects. It can be useful when the dataset is very large and using the entire dataset for each model is computationally expensive. There are key differences between them. Sampling method. Bagging uses sampling with replacement while pasting uses sampling without replacement. In the data utilization, in bagging, individual subsets may contain of duplicate instances, whereas in pasting, subsets consists of unique instances. Both techniques aim to leverage the power of ensemble learning to create more robust and accurate models by reducing the model's sensitivity to the training data's specific peculiarities. Bayesian beliefs networks. In this probability calculation, Bayesian networks use Bayes' theorem to calculate the probabilities of events based on prior knowledge and observed data. In the inference and reasoning, these networks can perform inference, making predictions or reasoning about uncertain situations. In the decision support, Bayesian networks can be used to support decision making by providing probabilistic insights. Training and visualizing decision trees. In the attribute selection, choosing the most informative features to split the data at each node. Pruning in the removing unnecessary branches to prevent overfitting and improve generalization. The visualization graphically representing the decision tree structures to aid understanding and interpretation. Challenges in machine learning model development. Developing machine learning models involves various challenges, including data quality and quantity, feature engineering, model selection, overfitting and underfitting, hyperparameter tuning, computational resources, interpretability. In the data quality and quantity, obtaining sufficient and high quality data can be difficult. Models require large data sets and the data must be clean, well labeled and representative of the real world scenario. In the future engineering, identifying and creating relevant features from raw data is critical but often challenging. This process requires domain knowledge and can be time consuming. In the model selection, choosing the right algorithm for the task at hand is not always straightforward. It requires understanding the strengths and limitations of different models, overfitting and underfitting, balancing the model's complexity to ensure it generalizes well to unseen data without memorizing the training data is a common issue. Hyperparameter tuning. Optimizing hyperparameters to improve model performance involves extensive experimentation and can be computationally expensive. In the interpretability, making models interpretable and understandable to stakeholders, especially with complex models like deep learning, can be difficult. In the maintenance and updating, models can degrade over time as the underlying data distribution changes. Continuous monitoring, updating, and retaining are necessary to maintain performance. In the ethical and bias concerns, ensuring models are fair, unbiased, and ethical is critical, as biases in data or model design can lead to unfair and or harmful outcomes. Security and privacy. Protecting data privacy and ensuring the model's security against adverse attacks are significant concerns, especially with sensitive data. Conclusion and key takeaways. Understand the fundamentals. Familiarize yourself with the different types of machine learning algorithms and their applications. Develop end-to-end projects. Practice applying the full machine learning workflow from data collection to model deployment. Continuously learn and improve. Stay up to date with the latest achievements in the machine learning. Continuously refine your skills. Thank you for watching my video. Please like, share and subscribe.